Recurring decimals. If the fraction a over b is written in simplest form, then a over b has a repeating decimal representation that does not terminate if and only if b has a prime factor other than 2 or 5. Now, a repeating non-terminating decimal can be expressed as rational number a over b, where b is not equal to 0 and a and b are integers. So this is what we are saying. If we have a fraction, let's say 2 over 33, we are saying that because 33 has prime factors other than 2 or 5, this is going to repeat without terminating. 2 over 33 will give you a repeating and non-terminating decimal. Now, if you have 5 over 7, this one is going to give you a repeating and non-terminating decimal. So the prime factors other than 2 or 5, if they are in the denominator, they are going to get a recurring decimal. We are saying prime factors apart from 2 or 5. So we could also have something like this: 1 over 55 is going to recur, even though there's a 5 there, but because there's a presence of another prime number, which is 11. So 1 over 5 times 11. That is it. So because of the 11 here, this is going to recur. Left with the 5 alone, this will not recur. Now let's take some work example. We want to express 0.4 recurring in fractional form. Now note that you can either use the dot or the bar to indicate that it is recurring. So the bar and the dot shouldn't confuse you. They are all the same thing. So if you want to express 0.4 in a fractional form, this is how we have to go about it. 0.4 recurring. It is a bit different from the terminating decimals. So let's see how we go about it. What we need to do is to take care of the repeating pattern. So if you let x to be equal to 0.4 recurring, so we can write this as x is equal to 0.444 recurring. So let this be our equation 1. Now if you multiply equation 1 by 10, it's like multiplying this one too by 10 because it's the same thing. So you're going to get 10x to be equal to 4.4444 recurring, which is 4.4444 recurring. Now, don't forget that the 4s are many over here. So if you move 1 by 1 decimal place, we can still continue, still recurring. Now we can rewrite this as 10x is equal to 4.4 recurring. So let this be equation 2. Now if you take equation 2, if you take equation 1 from equation 2, you are going to realize that this is going to take off this. We are left with a 4. So 10x minus x will give us 9x, and 4.4 recurring minus 4 recurring will give us 4. So this implies that our x is equal to 4/9. So this is how to write or to express a recurring decimal in a fractional form. Now, in general, if you multiply by 10 raised to the power n, where n is the number of digits in the repeatant, so the repeatant is the 0.4444. So the number of digits there is 1. So if you multiply by 10 to the power 1, in this case, because now for this one the repeatant is 0.4444. Now it is only one decimal place that is repeating. So in this case our n is equal to 1. So we that's why we multiply by 10 to the power 1, which was 10x, which gave us a 10x. So if it is 2 decimal places that is recurring, then we multiply by 10 to the power 2. So let's look at this one. This time 2 decimal places is recurring. So we let our x to be equal to 0.34 recurring. Then we can see that 2 decimal places is recurring. So if you multiply by 10 to the power 2, 10 to the power 2 will give us 100. So that will give us 100x will be equal to 34.34 recurring. So this is equation 1 and this is our equation 2. So now let's take equation 1 from 2, equation 1 from equation 2 will imply that we have 99x to be equal to 34. So our x now will be equal to 34/99. Now let's look at this one too and see. We are expressing this in fractional form. So in this case, we still have 2 decimal places repeating, or we have 2 decimal places in the repeatant. So we are going to multiply by 10 to the power 2, which is 100. But look at something. This one is not repeating. So you have to cater for that one first before you multiply by 100. So let's cater for this one first, the non-repeating part first. So in case the decimal, or in case whatever you are asked to convert is consisting of the non-repeating part and the repeating part, you have to cater for the non-repeating part first. So if we let y to be equal to 0.123, then 34 recurring. Then we multiply to cater for the non-repeating part. We multiply by 1000. So we get 1000 y will be equal to 123.34 recurring. Now, so this is equation 1. So equation 1 by 1000 give us this, which is equation 2. Now, we need to cater for the repeating part now, which means we should multiply by 100,000. So If you multiply equation 1 by 100,000, we are going to get 1, 2, 3, then 34.34 recurring. So this implies that we have 100,000 y is equal to 1, 2, 3, then 3, 4, 3, 4 recurring. So this is our equation 3. Now we take equation 3 from this. We can take it from this because this is the one that are having the repeating pattern on the other side of the decimal point. So equation 3 minus equation 2 will be equal to, will imply that, so this implies that we have 9900 y is equal to 12211. 12211. So our y will now be equal to 12211 over 99000. So that is this in the fractional form. Now the same thing applies to this one. The same thing applies to this one. But this one, you can do it like this. This is like 17, 17.12531, then 531 recurring. It is the same as 17 plus 12, then 531. This one is like 17 plus 0.12. So this is a point, 0.12531 recurring. So this is already in the fractional form, which is 17 over 1. So we need to cater for this and add it to the 17. So let's take this part now and deal with it. So we have let x to be equal to 0.12, then 531. Okay, then if this one will be y, then it means our y will be equal to 17 plus what? X, which is what we are looking for. So let's call this equation 2 equation 1. If you like, you can, this one is not necessary, but if you do it too, it's not for presentation purposes. So now it means this is our y. This is our y. So y equal this for presentation purposes. Now let's change the x to a rational number. So like we know, we cater for this first by multiplying equation 1 by 100. So equation 1 by 100. And this will give us, this will imply that 100x 100x is equal to 12.531 recurring. So we need to cater for the repeating part now. So this will give us our equation 2. Now we multiply this by 1000. So we are going to get 100,000 again. So we have 100,000 x will be equal to 12531.531 recurring. So this is our equation 3. So now we take this from this to obtain, take this from this. So equation 3 minus 2, equation 3 minus equation 2. So this will give us 99900x is equal to 12519. So our x now is equal to 12519 over 99900x. Sorry. Zero zero. So now our y will be equal to 17 plus x, which is 12,519 over 99900, and this is the same as 17 whole number 12519 over 99900. So this is how we express this in fractional form. You can also take the whole thing at a go and do it. You get this as an answer.